So for those of you who don't know me, I'm Michael Still. I'm a Canberran, born here, lived here my entire life, apart from 4 years when I didn't, and that was a horrible mistake. So that's a little bit weird for me because I've also been an OpenStack developer since 2011. So I think I'm the longest serving OpenStack developer in Canberra because I'm amazing. My first commit was in January 2012. And of course it's a please fix this typo commit. So, I've come a long way, shall we say. I'm a OpenStack Compute core reviewer. OpenStack Compute is the big boy name for Nova, which means I'm one of the smallish number of people who can approve code to land in Nova. I'm a former Compute PTL, which means I was the elected guy who gets blamed for 2 releases. And I've served on the technical committee. So Tristan this morning mentioned that he used to serve on the board. The board do all the boring business stuff we like to pretend isn't needed, like certifications and trademark licensing and blaming the developers for stuff. And the technical committee does all the really important technical stuff, like blaming the board for all that stuff. So there's kind of a technical and business divide. And I also, as a punishment for my sins, manage a team of OpenStack developers in Australia now. So there's about 10 of us. We also have 5 tech writers, but they report to someone else because she doesn't like me. And we have a product person floating around. So Rackspace has about 16 upstream OpenStack people in Australia, which is cool. There's also 5 of them in the room, which is what that sniggering in the back corner is. Now, it's really hard when you're writing these talks to work out who the audience is. Is this a really serious audience? Is this an audience that's met me and realised I'm not very good at serious? So the next slide is a test. I was thinking about this a lot this morning. So I started working on OpenStack in 2011 when I looked like this. Now, interestingly, this is a relatively recent photo of me. So we can draw a conclusion here. OpenStack gives you grey hair and weapons. So it might also be because I'm older, but I think it's just the OpenStack thing. I also very much don't want to sell you anything today, apart from OpenStack in general. I feel obliged to say I work for a company called called Rackspace. We're not very well recognised in Canberra, I think because we mostly do hosting for corporations, not government stuff. We're one of the 2 original founders of the OpenStack project, and we're the founder that still does OpenStack, which is cool. And that's enough about us. I just want to say we exist, pretty much. So what's big data? Hopefully you haven't been under a rock and you're at least aware of the term. That said, I'm going to provide some basics in case you have been under a rock, I suppose. But the basic idea is to store and process large volumes of data on large quantities of inexpensive commodity hardware. It's pioneered by internet companies like Google and Yahoo, but it's now being used by a lot more traditional organisations, banks, government departments, Fortune 500s, people like that. So in the good old days, you'd go out and you'd give all of your money to someone who'd give you an amazing machine like this one with the blinking lights. I picked this for a reason. This is a Thinking Machines Connection Machine 5. A&U had one of these when I was in year 11, and it was amazeballs because flashing lights. They actually told a story at the time that this machine was funded because the general in charge of computer science R&D funding at the US Department of Defense really liked the blinking lights. So you literally give all of your money to these guys and they'd give you this cool thing. This machine had 32,000 processors in a single box with some really specialist interconnect and some crazy data storage. And you'd use it for what was considered big data back in the day. These days you'd do this. This is an actual photo of a Google data center smuggled out by someone who gave their life to get it. Or I Googled it, it's hard to tell. These are thousands of white box machines that are so cheap they don't even have a brand name on them. They came from a company like Quanta or Supermicro, but nobody even knows who because they don't care. And they pay about 1/10 of what you do for a machine because they also don't care if they break. And they just have lots and lots of them. So they solve the unreliability problem at the software layer instead of the hardware layer, if that makes sense. I think what I'm trying to say here is machine counts are increasing. What people are doing now is instead of having one big box and some people in lab coats with PhDs to manage it, you're getting lots and lots of boxes and a smallish number of people to try and manage them. So we're talking about hundreds or thousands of machines, not 1, 2, 3 kind of scale. And because the universe is mean, operational budgets are not increasing at the same time. They're certainly not increasing in a linear manner with machine count. So we need to do something to make managing these machines cheaper per machine. And obviously the answer is to automate more. So OpenStack from day zero has supported virtual machines, and I feel like we kind of all know what a virtual machine is. Because OpenStack is cool, we call them instances, because that's what Amazon calls them. But an instance is in almost every case just a virtual machine. Virtual machines are not a good choice for big data, to be blunt. You see people doing this, and it's cool if it's a proof of concept, or like, I don't know, your devs need to test that things work, but I wouldn't be doing it in production. Virtual machines have a performance impact. It's only a few %, but at scale you'll notice it. Like if you have 1,000 machines and you lose 5%, that's like 50 boxes, right? The big data data storage system is also trying to replicate your data to deal with the unreliability of the machines. If you're running on virtual machines, it'll be replicating the data, but it's entirely possible that all those VMs will end up on a single hypervisor, at which point your data isn't anywhere near as replicated as you think it is. And in fact, it's not simple. You can't just use, say, a constraints language to say, you know, at a trivial case, you can't say, I've got 3 hypervisors, and I store 3 copies of the data, so let's break it into 3 vertical silos. Because Hadoop, for instance, doesn't always store all of the blocks in a predictable order like that. It just picks an arbitrary 3 machines. So that's not going to work properly. So big data is about bulk, and it's also not about artisanal machine orchestration. You know, you can't have complicated constraints stuff or whatever. You just, at non-trivial, anything other than trivial scale, want bare metal. So back in the mists of time, late 2012, there was the Folsom Design Summit, and these research scientists from Japan came along and said, we've noticed this cool thing called IPMI, and you know, we can treat real physical machines a bit like virtual machines. And so they wrote this thing called the bare metal driver in Nova, and it was horrible. It turns out that real machines are not virtual machines, and there's a whole bunch of stuff you want to do with them that you just can't. You can't snapshot them. You can't randomly add and remove disks with API calls without a dude showing up with a screwdriver. All of that kind of stuff. But people did deploy it. Yahoo today has tens of thousands of machines running on this bare metal driver. And they seem relatively happy, but that's because they've also hit it with a hammer to meet their exact use case. So luckily some adults came along in 2013 and made this a thing. So they took the research project and they read it, had a chuckle, and threw it away. And then they sat down and started writing one from scratch as a separate OpenStack project. It's called OpenStack Bare Metal to the big boys, or ironic to the developers, because isn't that ironic? Sorry. And what they've built is actually pretty cool. So the new implementation, like I said, is a separate project. It can manage machines with all of the things you'd expect, IPMI, DRAC, ILO. It's actually got a pluggable infrastructure, so if you're using something really bonkers that doesn't talk those things, like, I don't know, a product from IBM, then you can do that as well. But the reality is, in our experience deploying this for customers, we're yet to meet a machine that doesn't work well enough with IPMI to just use the IPMI driver. That said, we haven't used every vendor on the planet, but we've used 5 or 6 of them now. So what OpenStack Bare Metal does is it provides a service to OpenStack Compute that lets us deal with the differences between virtual machines and physical machines by making that other project deal with that stuff. So you can still treat these machines as instances in, say, Horizon or the APIs or whatever, but there's an abstraction layer that makes it easier for Nova to have a coherent story about how these things work. There's still some stuff you can't do. You can't snapshot, for example, and you can't magically, code away the man with a screwdriver if you want a new hard disk. But you can, to a large extent, just treat these things like instances now. Now that means we have API control of bulk infrastructure. So we're kind of just starting to come around full circle again. So we've got increasing machine counts. We've got an operations team that isn't increasing in size. But now we can treat the machines as just things that we create and destroy with APIs or command line tools or a clicky web thing, whatever you want to do. So now we can start to automate some of the jobs that that operations team do so they can start handling larger numbers of machines per person. So for example, what you'd probably do is you'd build a machine image that was a master node or a zookeeper node or a data storage node or whatever, and then you'd just use API calls to deploy those. And so, for example, if a data storage node starts acting weird, you wouldn't have someone log into it and try and fix it. You'd hit it with a hammer until it stopped, like that instance went away, and you'd boot a new instance, and ta-da! Theoretically, if you did that a couple of times and it still wasn't working, then you'd probably send someone to diagnose what was physically wrong with the hardware. Or you'd mark that piece of hardware as bad and go get another one via the API. Like, ultimately, you still have to have a human in the data center, but you can automate things to the extent where you hand them a list of broken machines each morning and off they go. So I've spent the last year helping a customer do this. Why did it take a year? Because they want more than this, of course, because they're a customer in the real world. So they wanted continuous deployment of OpenStack with their Hadoop application ebits. So basically they said, look, we've done some maths, and every time we stop the world and deploy a new version of Cloudera, which is their chosen Hadoop flavor, and our management stuff, we have to do 2 weeks of testing, manually with a man clicking and all of that. That testing costs us millions of dollars. So instead what they wanted to do was automatically deploy the entire stack every couple of weeks and not do all the hand-clicking testing. And if something broke, you'd know because things stopped working and you'd just roll it back. And that would cost them a lot less than a couple of $1 million per release. It would also mean they'd actually do it occasionally, because it's really hard to go to your boss and say, I want to spend a couple of $1 million on this thing with a slightly different version number with no detectable differences. It's not a good sales pitch. And so we did that thing for them. So we can now continuously deploy OpenStack. The way we do it is we actually have 2 OpenStack installs and we alternate between them. And then we move the workload between the 2 installs. But that's kind of not the point of the talk, so I'm happy to chat about that later if people are interested. But it meant I learned a lot more about Hadoop than I did previously, and I think some of that is of interest. So what I'm going to talk about is a simpler version of their deployment. I think basically we have some recommendations for how you would do big data with OpenStack now that are kind of more general than just the crazy people who wanted continuous deployment. So Zookeeper nodes, if you know anything about Hadoop, are kind of like the name nodes. It's where you go and say, where is my thingy? So, you've got an application, you say deploy it to a cluster. You don't really know where in the cluster it ended up. Zookeeper is the thing that ties everything back together. It's harder to do deployment on bare metal than I thought it would be. Management nodes are even harder because they're the artisanal little Cloudera or whatever user interface that lets you clicky manage things, and they tend to be hand-built. But the good bit is processing and data nodes are really easy. So you know what? The vast majority of your machine count... wait, I've missed it. The vast majority of your machine count is the data and processing nodes. So the punchline is start there. Don't worry about the bits that are harder because they're edge cases. But if you've got 1,000 machine Hadoop install, probably 990 of them are data and processing nodes. So that's where I would start. And we did actually get Zookeeper nodes working as well. We haven't even tried with the management node because there's only one of them. So it's just a lot of engineering work for a thing that doesn't have a lot of benefit. So Zookeeper is possible, but it's just harder. So the way we're doing data and processing node deployment for these people is that you build a golden image of the way you would like a data or processing node to look. Because of the limitations with bare metal, you can't just build a single machine and snapshot it, which would be super tempting. What we do instead is we use a tool called Disk Image Builder to build a... Wow, I can't believe I'm saying this. We use Disk Image Builder to build an image of a disk. Aha! You'll never remember what that thing does. And then... So that image has the OS and the Hadoop software install, whatever application GUI you need, all of that kind of stuff. And then you keep the data that the cluster is storing on disks separate to that. And then when you want to update, say, the OS image, let's say we have a heartbleed or something happen, what you do is you build a new golden image, and then you can use Nova's rebuild command to rebuild the box. And so basically with the rebuild command, you say, this instance, I really wish that its root disk looked like this one now. And Nova says, oh, okay, there you go. And there's a feature in Nova that I thought was crazy at the time it was added, and I'm happy to admit I'm wrong, called Keep Ephemeral, where what you can say is when you rebuild or deploy a new instance, don't bother reinitializing the non-boot disks. And so when you keep your data on those other disks, we don't have to resync the data to the node when we change the OS. The reason you want to avoid resyncing the data is if you're, say, fixing a security vulnerability in your OS, you're going to walk through the entire cluster and reinstall everything. And then if you have to resync all data to all machines, you're just going to saturate your network resyncing data and you won't be doing any user traffic. And so that's super cool too. You can, is it optional or not? You can still scrub disks between tenants, but I think the reality is if you have a multi-tenant environment, you'd be a tiny bit brave to be using bare metal. Because, for instance, you're trusting the OS you boot on the machine to not have mucked with the firmware on the South Bridge or something like that. So, you know, we don't have to worry too much about that case. Zookeeper nodes are harder because the config for the Zookeeper nodes needs to be the same on every node, and that config specifies all the other Zookeeper nodes. So basically there's, I think they called it peers, but there's basically a list of your friends. So you say, I'm a Zookeeper node, and these other 2 nodes, or whatever, depending on your cluster size, are Zookeeper nodes as well. And then you have to make sure that remains in lockstep. It's even worse because the clients, at least with the Python client library, also have a list of what the peers are. And so you have to keep all of that stuff in sync. We solved this by using an overlay network. So because we have 2 OpenStack installs, we couldn't use floating IPs to say, look, these 3 IPs will just be the Zookeeper nodes. So we just overlaid a network on top of the 2 OpenStack installs and said, we know what IPs these machines will be at, and so we can bake those into the image. The reality is if you're using a single OpenStack control plane, because you're not doing continuous deployment, then you can just use floating IPs and this isn't too bad. We also did some tests here. We were, again, worried about the data replication costs, so we took the biggest Zookeeper database that this customer had and we increased it by a factor of 10. And then we had a giggle when we realised that that meant it was only 10 gig or something. And replication times are like small enough that no one even notices that you do it. So it turns out that bit wasn't a particular problem. So I've kind of been talking fast because we started a bit late, but I've got a couple of little unrelated things I want to talk about as well. So as a punishment for my sins, I also used to be the MEETUP organiser in Canberra. We hired some people and then I tried to trick one of my subordinates into doing it and he's mutinied and not done it. Partially that was because the OpenStack meetups here used to be a room full of vendors trying to sell to each other and that was really sad. So I'm actually excited that there's users in this room and I'd like to try and get the meetup going again. Other people have been talking about hiring problems and retention problems and stuff like that. And I think part of the solution there is to have a more active community locally so that we all get better at growing new people. The reality is I've never successfully hired an existing OpenStack person. I've always had to grow them because existing OpenStack people are really hard to find. So I think there's scope here to start talking as a community about, you know, how do you train your people? Oh, this is what I do. Oh, that's interesting. Could we share some resources? All of that kind of stuff. I've made an ambit claim. I've created an OpenStack meetup for the 29th of November as an arbitrary choice instead of waiting until next year. That's a short link to the meetup page. I haven't picked a venue yet because I don't have one. We don't have a building in Canberra. So if anyone wants to volunteer a location, that would be cool too, if you could talk to me. But worst case, I'll go and hire a bar, which is what we did last time. And that has the advantage that bars have beer, I've been led to believe. So according to me, we have 5 minutes left. So are there any questions? Apart from why does that guy talk so fast?
When you're looking at 1,000 bare metal deployment, did you run into any issues between Ironic and Nova and race conditions between them based on scheduling?
Interesting. No, the only scheduling problems I've seen with bare metal were around the O case. So O had this thing back in the day, it may not be true, I haven't looked in a while now, where they had, say, 50 machines and they would want to boot exactly 50 machines all at the same time, and the scheduler falls apart in that case, where it starts getting confused about, you know, what remaining resources it can hand out. So basically, if you have no headroom, you hit pain. Because we do rollouts in this kind of exponential staged way, we haven't experienced that problem. And in fact, in the secret customer I cannot name case, it's pretty steady state, right? Unless they're rolling in a new rack of machines, they actually know how many machines they have, and what they're actually doing is rolling through doing rebuilds. They're not, say, tearing down the entire cluster and building it again. if that makes sense.
I've actually got a question.
Oh dear.
Slightly different though. Michael, one of the things with the community, those who don't know, those who make it to be a PTL and live through a PTL and don't go run screaming can be a hard thing to do. When you look back on your time in the OpenStack community, what advice might you give yourself in getting engaged with the community and what you did as a PTL or just anything like that? Because you've always been a pillar in the community, and I think you've had to form a very thick skin because of it. But I'm just wondering what your kind of reflections on that are.
I really like how you suck up, by the way. I'm enjoying that bit. Wow, so there's kind of a couple of questions there. Ignoring the PTL bit for a second, what would I say to a new contributor? The one thing that's happened to me, for want of a better set of words, from working on OpenStack is I'm a much, much better programmer than I was 5 or 6 years ago. Because you upload some code and someone will say, you don't know how to program, have you considered this? You go, nope. And iteratively you get really good. It's a great way of learning if you can put up with people saying no all the time. The other problem, especially with Nova, is Nova's really big. Last time I looked, it's like 5 million lines of code or something, with a lot of really weird history at this point, like 5 or 6 years of, we did it that way once and we face planted and it really hurt. And so the core team spends a lot of time saying, it's cool that this fix works for you and fixes your problem, but it won't work for our other millions of users for this really subtle thing that no sane person would have ever thought of. And so that can be really hard. And so we try to coach people, but I think we come across as standoffish and kind of know-y, because when I look at the review queue, we have 800 outstanding reviews, and so we don't have a big time slice per review. So I'd say, hey, try to read review comments in a really positive way. We don't hate you. We don't want you to go away, but we do have this very large community of people we need to protect. And one of the ways we protect them is by being conservative. On the PTL front, I think one of the things I learned is that all management problems are about talking more, as best as I can tell. At the time where I inherited it, we had a team that didn't really like each other and we fought a lot, and we spent 2 releases actually focusing on talking more instead of the technical stuff. And I look at us now, and at the last summit, we didn't have any arguments at all, which was weird because we used to literally have shouting matches. So I think we've kind of, and I can't take all of the credit, but I think as a team we found a way to work better and kind of all pull in the same direction. And now when we're shouting at people, we're shouting at the people who come along and said, I just want my crazy fix for my weird product that nobody uses. Because there's always got to be shouting. So yeah, does that sufficiently answer your question?
No, that's priceless. And yeah, I'm really glad to see the Canberra meetup. I will actually make the effort to come out myself, just because it was a good event. So it'd be good to get everybody back together, especially because how many Rackspacers are based in
There's
Canberra?
5 Rackspace people in Canberra, because Canberra is awesome.
Yep.
And there's definitely deployments here. It's just we've never had a great way of reaching out to them and saying, I'd buy you a beer if I knew who you were. And also, if you come, you can buy them a beer. So that'd be cool.
I would gladly do that, actually. And along those lines, please give Michael a round of applause for a great presentation.